In this lecture, we'll introduce the different data types in a Java program, and we'll also see how we can use them in expressions. It's worth noting that different programs manipulate data differently. And there are different types of data. I mean, there's a whole variety of different data. We have, for example, the set of integers, and we can do certain things with it. We would have a set of single-lettered characters, and we can do different things with it. And we also have a set of numbers with decimal places, and we can do things with it differently than we can do with integers or characters. So what Java does is it categorizes our data into these different types. And the key thing with these types is that we can perform only very specific operations on a given type of data. So like, for example, we can't add up the letters of the alphabet. I can't go the letter A plus the letter B equals the letter C. I can't do that. Now I can do other operations with characters that I can't necessarily do on an integer, for example. So to give a formal definition, a data type is just a set of values combined with a set of operations that we can perform on those values. We'll focus more on primitive data types for now. And there are three different categories of primitive data types. We have integrals, which is simply values that deal with integers. We have floating point, which are values that deal with decimal numbers. And we have Boolean, where we deal with logical values, or pretty much it's either true or false. Now, the integral data types can be classified even further. So we have character, byte, short, int, and long. And each of these types would have its own set of values associated with it. I mean, they're still storing integral values, but they have different ranges of values that they can store, and they have different storage requirements in order to get those ranges. So here's a table of all these different types. So with our character, for example, we can store anything between 0 to 65,535. So remember, this is where Unicode comes into play. So we can take the numerical value and convert it to the appropriate Unicode character. And we would need 2 bytes or 16 bits in order to store that. A byte will allow us to store a value in the range between negative 128 to 127. And this requires only 1 byte or 8 bits. A short gives us a bit of a larger range to work with. We can store anything from 2 power 15 to 2 power 15 minus 1. And this requires 2 bytes or 16 bits. Now, realistically, most programs these days never use bytes or short. These were more common a long time ago when memory was more constrained than it is today. The most common integral data type we use is the int. And this stores a value between negative 2 power 31 to 2 power 31 minus 1. And traditionally, only 4 bytes are needed for storing an integer. Now, if we need something that has a larger range to work with, but you still are only storing an integer, you can use a long, because we can store a value anywhere between negative 2 power 63 to 2 power 63 minus 1. And we would need 8 bytes or 64 bits to store it. Most programs nowadays use a character, int, long, or a combination of them. So as we said, the most commonly used integral data type is going to be the int. Now, if we're going to use it, there are 2 rules that we have to remember. The first rule is that positive integers don't need a plus sign. You can put it in there, but it doesn't do you any good. So I mean, if you want a negative value, you must put a negative sign in front of it. But for positive values, you do not have to include a plus sign in front of it. Second, no commas can be in the integer. So for example, if I try to do something like 5,000, if I try to do 5, comma 0, 0, 0, let's make this more like a 5. There we go. This is invalid. If I try to put this in my Java program, it's going to be wrong. It's going to be a compiler error. So we do not want to do that. So we do not have commas in our integral value. So even if it is a large value, no commas in there. And the same rules apply for the byte, the short, and long integral data types. Now, what about characters? Well, a char variable represents a single character. And when we say a character, we're talking about letters, digits, and symbols. And each character must be enclosed within single quotes. So just to give an example, if I wanted to store the capital A, I have to surround it with two single quotes. That's how Java recognizes characters. Now you might be wondering, well, what about a blank space? No, we can do that. We would just put the space in between single quotes. So we would just have the quote, we would hit the space bar, and then another single quote. So that gives us our blank space. Now, the key thing about characters is that only one symbol, okay, I'm going to repeat this, one symbol can be placed between the single quotes. So, for example, if I try to do ABC in single quotes, this is not a valid character. This is more along the lines of strings, and we'll get into more details about that later. But if you want to use a character, you can only have one and only one character in the single quotes. Now, as we said before, we're storing an integer value in the character. So how does that work? Well, each of the values in there, each of the 65,536 values represents one of the Unicode characters. So if we go back to our A example, the number 65 represents the letter A. And each of these values is called a collating sequence. And what's nice about the collating sequence is we can use them to compare characters. So let me give you an example. Let's say we wanted to compare the letter A and the letter B. Well, the number 66 is the collating sequence for the letter B. So when I compare A and B, I'm actually comparing the collating sequences. So I'm comparing 65 and 66. And since 65 is less than 66, that means the letter A is less than the letter B. Now, it's also worth noting that there are some very specific characters that allow us to put a slash in front of it. We'll go over some more details with this later, but it's just worth noting that this is the only exception where we say that a character can only have a single letter, digit, or symbol. So these are very specific types of characters where we can actually have two different symbols. So here are a couple of common examples. The /n is what we call the new line character. We can include this in an output statement if we wanted to have something start on a brand new line. The /t is the tab character. And this is normally used when we want to print a tab in our output, so a bunch of spaces together. And the /0 is the null character. We don't use this as much in Java, but in other languages, this is used to let us know when we're at the end of a particular string. Now let's take a look at the Boolean type. And as we mentioned already, a Boolean type is simply a variable that stores only one of two possible values, either true or false. So these variables are used to evaluate logical, or what we call Boolean expressions. And what's nice about this type is that we only need one bit to store a Boolean value. Because I mean, think about it, we're saying either true or false. So the easiest way to do that is just by storing either a 0 to represent false or 1 to represent true. We really don't need anything else to say whether something is true or false. And the last primitive data type is the floating point number, which Java uses to represent numbers with decimals. And this is actually very similar to scientific notation. So just to give an example, if we type out 75.924, the way it would actually be represented in Java is the scientific notation. So it would be 7.592400. And so that would be stored in one place. And then the other part would be the exponent, so the 0, 1. And then Java uses that information to calculate its number. Now we can get very specific here and see that there are two different types of decimal numbers. We have the float and the double. So we have a table that shows the difference between the two. So a float can store a set of values, negative 3.4 to the 10 to the 38th power, all the way to 3.4 times 10 to the 38th power. We would need 4 bytes for this. And for the numerical part of it, this part I'll highlight up here, which is actually what we call the mantissa, the precision there would be about 6 to 7 decimal places. It kind of depends on your system. Now the double gives us a much larger range of values to work with. So we can go from negative 1.7 times 10 to the 308th power all the way to 1.7 times 10 to the 308th power. And only 8 bytes are needed for this. And we would have 15 decimal places of precision. But let me make this very clear. We're not storing a complete value, so it's not 100% accurate. So when we say that we can store up to 1.7 times 10 to the 308th, but it's only going to go up to 15 decimal places. So the first 15 numbers, or I should say the first 15 digits of the number, would be what's actually considered in our calculation. The remaining digits are completely ignored, and that's how we get away with only using 8 bytes to store such a large number.